Okay, welcome back for some more diagonally launched projectiles. Um, Hopefully, again, you tried the problem from before, tried to set it up and actually put in the variables. Now, I want to be clear that that's really just algebra practice that you were doing. You didn't practice any physics. Okay, the physics was in creating, the diagram and in creating this chart here, figuring out what these different things were, and then plugging them into the equation. So don't get too comfortable if you realize that oh yeah, I watched the video and then I got the right answer. Because the truth is, that was the easy part that you did. So I'm glad that you could do it if you did get it right, but nevertheless, I want you to realize that filling out this chart, that's the most important part for you to learn, and that's what you're really going to have to practice. Okay, so if you're not getting this, and if this doesn't make sense, well, you pass algebra, but you don't pass physics. So make sure that you understand why all these variables are up here. So this is what we had at the end of the last video. We want to remind you the most important part was we had found that the x component of the initial velocity was VO cosine of theta. The y component was VO sine of theta. Okay? And now what we need to do is we actually need to solve for those two positions. We need to solve for delta x, and we need to solve for delta y. We can do that pretty simply because we have basically everything. What I'm going to end up doing is plugging in to this equation for x. There are many equations that you can choose from, especially because we have so many variables here. And you probably could have done it a different way. I did not double check that this was the only option, but it is the one that comes to mind for me first, mostly because I know that a term's going to cancel out. And I also know that this is just kind of the first equation that comes to mind for me. This is the one that I tend to remember most. It's the one that seems to be most valuable to me. And so this is usually where I start. So I can look at this in the x direction. I can know that the acceleration is 0, so this whole thing crosses out. That's why I used this equation. And so I can simply plug in that delta x equals whatever its initial velocity was, which was VO cosine of theta, and multiply by t. Easy. Okay, this is the horizontal position. This is pretty much what it always comes down to, is that whatever the initial velocity is times the time is going to give you your position. And it's because horizontal motion is constant speed, and so it's very simple to calculate. Vertical motion is a little bit more complicated. We get delta y VOYT plus 1/2 AYT squared. And we need to realize that the vertical motion, because we're going up and then coming back down, signs are going to be very important. Positive and negative is very important. We need to realize that the initial velocity is positive, but that the acceleration is negative at all times. Even as we go up and stop and turn around and go the other direction, the acceleration is always going to be negative. And so I need to actually go ahead and plug that stuff in kind of from the very beginning. So when I plug in for the initial velocity, that's going to be VO sine of theta. It's going to be positive. That's not going to be a problem. However, the acceleration is going to be a negative value because g is in the negative direction. Mathematically, this should make sense. Basically, however fast I'm going at the beginning, minus the speed that I lose due to gravity, because gravity is going to slow me down. That's why I need to subtract that. Okay, and I actually have all of these different variables given to me. They are all given information or known constants, and so I am done. That is the end of my calculations. All right, so you should have gotten this for the y, basically, and that for the x. I'm sure you did a wonderful job of that. You probably got to this and said, oh, well, Can't do anything else, that's weird. I must be stuck. Well, you weren't stuck, you were just done. So, that's a diagonally launched projectile problem. Seems really complicated, but it's not. There are some specific situations that can be a little bit tricky, different kinds of questions they'll ask other than just what is the position. And so I've got another video of projectile tips that you might want to check out, which will help you to solve those more complicated situations. So, good luck.